Welcome to AI Paper Podcasts, where we try to cut through the noise and give you the core insights from the latest AI research. Today, we're diving into a really fascinating paper that's pushing the boundaries of text-to-speech. It's called EmoVoice, LLM-based emotional text-to-speech model with freestyle text prompting. Quite a mouthful, but the ideas are powerful.
Yeah, this one's definitely a significant leap. At its heart, EmoVoice is, well, it's a new kind of emotion-controllable TTS model. What makes it really stand out is how it uses large language models, LLMs, It lets you use these incredibly detailed, sort of freestyle natural language descriptions to control the emotional tone.
Freestyle, so not just picking from a list.
Exactly. Forget those rigid labels like happy or sad. Think more like prompting it with expressing supportive joy and pride in someone's accomplishment, really specific stuff.
Oh, okay, so it's understanding the nuance, not just like basic keywords.
Precisely. And it also brings in this unique phone boost variant. They call it EmoVoice-DB. It's inspired by chain of thought ideas, and it generates the sound units, foams, and the audio itself in parallel.
In parallel.
Yeah, and that dramatically improves the consistency of the speech. Plus, they introduced a whole new data set, EmoVoice-DB.
Oh, right, I saw that, a 40-hour English emotion dataset.
And built entirely from synthetic data, which is pretty wild. It comes with all those detailed emotion descriptions, too.
Okay, synthetic data. That's bold. And the results, does it actually, work well?
It absolutely does. EmoVoice hits state-of-the-art performance on both English and Chinese test sets. And yeah, even when it's trained just on that synthetic data. They've also explored using these cutting-edge multimodal LLMs like GPT-4o Audio and Gemini to actually evaluate the emotional speech.
Evaluating emotion with AI, that's meta.
It is. So it's really a holistic advance, pushing things forward on multiple fronts.
Okay, that high-level view sounds incredibly promising, especially that freestyle emotional prompting. But, for those of us who tinkered with current TTS, getting any genuine emotion feels like a huge uphill battle. What makes it so hard? Why can't these models just, feel?
Well, that's the core problem, isn't it? Human speech is just incredibly rich with emotion. It carries so much more than just the literal words. But existing TTS models, they really struggle with expressing that kind of nuance. Historically, a big limitation has been relying on really coarse, simple categories, angry, happy, sad.
The basic ones.
Exactly. It's like trying to paint a masterpiece with, just 3 primary colors. You just can't capture the subtle shifts, the complex emotional states humans convey so naturally.
Yeah. So the way we've been telling the models what emotion to convey has been too simplistic.
Pretty much. And even if we wanted more detailed labels, getting high-quality emotional speech data is incredibly difficult. These data sets are super scarce. The total available across multiple languages is probably less than 300 hours.
That's not a lot.
Not at all. And the ones that exist, often small, the emotion labels can be ambiguous, or happy might sound completely different from one data set to another. Many just give you a single adjective, which you can imagine is really limiting if you're aiming for fine-grained control.
Right. It makes training for subtlety almost impossible with that kind of inconsistent source material.
Definitely. And then there's the third bottleneck, evaluation. Even if you could train a model perfectly, how do you actually know if the emotion is coming across right?
Yeah, judging something so subjective seems like another major hurdle.
It really is. Subjective human tests, like using a mean opinion score or MOS, that's still the gold standard for accuracy. But it's slow, it's expensive. There are automated metrics like emotion-to-vec that try to quantify emotion in the audio signal.
Okay.
But they often have resolution issues. Think of it like a low-res camera. It gets the big picture, maybe, but misses the fine details. And their reliability for really nuanced emotion, it's still kind of unproven.
So the field has basically struggled to find a good scalable way to measure emotional accuracy beyond just general trends.
That's a good way to put it.
Okay, so EmoVoice isn't just trying to sound human, it's trying to sound like a specific human emotion, one we describe in detail. Moving beyond those simple labels, that feels like a massive leap. How does EmoVoice actually pull this off? Across the model, the data, the evaluation, what's the secret sauce?
Right, let's break it down. Starting with the model design itself. EmoVoice uses the Qwen 2.5 0.5b LLM as its backbone.
Okay, 2.5.
Yeah, and that's strategic. It taps into the LLM's knack for understanding text semantics and, importantly, analyzing emotion from text. And what's really cool is how it handles the freestyle prompting. Instead of needing some complex, dedicated prompt encoder, it just feeds the natural language description directly into the LLM. The input format is super simple, like, system, say this sentence with emotion of your description here and your text here.
Just like that, you just tell it.
Pretty much. It makes controlling the emotion feel really intuitive, almost like you're just explaining what you want to a person.
That does sound much more user-friendly. A big step up.
It is. And then there's EmoVoice-DB, that phone boost variant we mentioned.
Right, the parallel phones.
Yeah, inspired by Chain of Thought, where models sort of show their work. The key innovation is outputting phone tokens and audio tokens in parallel. Think of like a singer mentally running through the exact pronunciation of lyrics just before they actually sing the note.
Okay, I can picture that.
EmoVoice-DB does something similar. It predicts the individual sounds, the phones, at the same time it generates the audio waveform. This parallel thinking step really guides the audio generation, making the spoken words much clearer and more consistent, especially for tricky phrases.
That makes sense. Like an internal check.
Kind of. They also use something called semantic group modeling. Instead of generating sound token by token, it predicts multiple semantic tokens, maybe 3 in each step.
Okay, why do that?
It's like building with bigger Lego blocks. It speeds up training and makes the whole modeling process a bit less complex.
Got it. And the training itself, you mentioned 2 phases.
Yes, a 2-phase approach. Phase 1 is pre-training. They use standard large TTS datasets like Voice Assistant, which has over 3,000 hours of English speech. This builds a solid, stable base TTS model.
Just getting the basics down.
Exactly. Then phase 2 is fine-tuning. This uses a smaller set of instruction data, the data that includes those natural language emotion descriptions and expressive speech examples. That's what makes it controllable, what teaches it the emotional aspect.
And you said the English model used only synthetic data for this.
For both stages, yeah. Which is really a crucial point. It shows you can build these high-performance emotional TTS models without needing tons of expensive, manually labeled human recordings.
That really could be a game changer for speeding up research in this space.
Absolutely. It lowers the barrier significantly.
Which brings us neatly to the data itself. EmoVoice-DB. 40 hours, synthetic, built for emotion. Sounds almost too good to be true for researchers.
Yeah.
How did they create it without humans labeling every second?
It really is impressive. EmoVoice-DB gives you 40 hours of high-quality English emotional speech, over 20,000 samples. Either one has that detailed natural language emotion description. The magic is in the synthetic generation process. They use GPT-4o for the text and the emotion descriptions, and then GPT-4o audio to actually synthesize the speech based on those prompts.
Wow, so AI generating the prompts in the audio.
Exactly. This method gives them really precise control over the emotion, strong expressiveness, and a naturalness that's honestly hard to get consistently from real-world recordings, especially once you factor in labeling subjectivity.
So it's like a perfectly curated, AI-generated emotional library. Can you walk us through the steps? How did they build it?
Sure. It's basically a 3-step pipeline. Step 1, text and emotion description generation. They prompt GPT-4o to create diverse text, usually 15 to 25 words that fit specific emotions. The texts range from bits of novels, dialogue, observational stuff. They can even use capitalization to indicate stress points.
Okay.
And the emotion descriptions are very specific too. They're single present participle verb phrases like conveying a contagious, joyful atmosphere. Focus is purely on the vocal effect.
Very precise definitions, almost like a technical spec for an emotion.
You could say that. It removes ambiguity. Step 2, emotion speech generation. GPT-4o audio takes the text and the description and synthesizes the speech. They used 5 different speaker voices to get some diversity in there. And finally, step 3, post-processing. Even great models like GPT-4o audio might misread a word sometimes. So they filter out samples with a high word error rate, or WER, just to ensure top-notch quality and that the words match the script. The final dataset is also balanced across 7 core emotions: angry, happy, sad, surprised, disgusted, fearful, and neutral.
That sounds incredibly thorough. But okay, you've got this amazing model, this amazing data. How do you actually prove the emotions sound right? That evaluation piece still feels like the Mount Everest here.
It absolutely is. And this paper really digs into rethinking evaluation. They point out why standard metrics were for just checking the words are right, or things like emotion similarity and recall rate from emotion to VEC, well, they're just not enough for fine-grained emotion.
They're too broad.
Kind of. They show general trends, sure, but emotion to VEC, for instance, has resolution limits. Like that blurry photo analogy, it might tell you it's generally happy, but it misses the specific shade of happiness. Its reliability for nuance isn't really proven.
So it might catch sad, but miss melancholy or wistful.
Exactly, which is why human judgment, the mean opinion score, MOS, is still vital for checking emotional expressiveness, and if the model actually followed the detailed instruction, EmoVoice did a lot of human evaluations.
Okay, the human touch is still needed.
But here's where they did something new. They actually tried using state-of-the-art multimodal LLMs, GPT-4o audio, and Gemini 2.0 Flash to evaluate the emotional speech, getting AI to grade AI's emotional performance.
Right, the meta-evaluation. What did they find? Can AI judge emotion accurately?
Well, this is fascinating. At a high level, looking at overall system performance, the LLM ratings correlated pretty well with human ratings.
Okay, so far so good.
But when they looked at individual sentences, the correlation between LLM scores and human scores dropped way down. Below 50%.
Below 50%. Wow.
Yeah, it's a really important finding. It suggests that even our most advanced LLMs, while maybe getting the gist, are still kind of tone deaf when it comes to judging the subtle nuances of emotion and speech, at least compared to humans.
So they can generate it, but can't reliably evaluate it at a fine level yet.
Exactly. Gemini's scores were apparently a bit more stable than GPT-4o's, but both fluctuated quite a bit sentence by sentence compared to human raters. It really highlights this urgent need for better human-aligned metrics for fine-grained emotion evaluation. It's a reality check.
Okay, so acknowledging that evaluation challenge, what about EmoVoice's actual performance number? How did it stack up against other models in the tests? And what did the team learn from digging into the model's components?
The results are genuinely strong. On their own English EmoVoice-DB test set, the EmoVoice 1.5 billion parameter model achieved what looks like state-of-the-art balanced performance. It got the highest emotion similarity score, high recall rate for emotion classification, while keeping a really low word error rate, just 2.62%, and high subjective quality scores.
So accurate words, right emotion, sounds good.
Pretty much. They found it rivals models like GPT-4 minutes on consistency and expressiveness, and actually surpassed it on overall speech quality.
That is impressive, especially from synthetic data. How about Chinese?
On the Chinese CCAP test set, EmoVoice-PP, the phone boost one, came out top across the board. Lowest year, highest emotion scores. And notably, it significantly outperformed the GPT series models in Chinese. Apparently, the GPT models had some issues there with unnatural prosody or accents.
Interesting. So the EmoVoice architecture seems pretty robust across languages.
Would seem so.
And beyond the headline results, what about those ablation studies, where they took bits out or changed things to see what mattered most? What did those reveal?
Yeah, the ablations give you the why. First, looking at output structures comparing audio-only, sequential, interleaved, and their parallel approach. The big takeaway. EmoVoice-PP with parallel foam and audio tokens massively boosted content consistency. Lowest wear in pre-training and on a tough test set with tongue twisters and rare words.
So that parallel foam prediction really works.
It confirms the value, yeah. Having the model think about pronunciation first makes a difference.
Okay, what else?
They looked at LLM size, 0.5 billion versus 1.5 billion parameters. Scaling up did generally help lower wear, better emotion scores, better subjective quality.
Right.
But the gains were somewhat limited by the dataset size, and obviously the bigger model costs a lot more computationally, so diminishing returns, perhaps.
A familiar trade-off. And the LLM initialization. Did starting with pre-trained LLM weights help?
Oh, massively. Significant benefits across the board. Lower wear, better emotion similarity, better recall. It clearly shows that the advanced language understanding baked into those pre-trained LLMs transfers really effectively to the TTS task. It helps with both getting the words right and getting the emotion right.
So leveraging existing LLM knowledge is key. Makes sense.
Absolutely. It's not just about the size, but the quality of the starting point.
And lastly, data augmentation. Did just rephrasing the emotion descriptions make a difference?
Tremendously, yes. They used GPT-4o to rewrite the emotion prompts, keeping the core meaning but varying the wording. This dropped the wear significantly from around 3.8% down to 2.7%.
Wow, just from rephrasing.
Yeah. By showing the model different ways to describe the same emotion, it boosted its semantic understanding, made it more robust, better at generalizing. All their best state-of-the-art results actually used this augmentation.
It shows how crucial diverse data phrasing can be, even if it's synthetic.
Definitely. Small tweaks, big impact.
So we've really dug into EmoVoice here, explored how it's pushing emotional TTS forward using LLMs, smart synthetic data generation, that clever parallel phone processing.
Indeed. EmoVoice is a powerful demonstration. It shows you can combine these advanced LLMs with smart architecture and synthetic data to get fine-grained emotional control. It proves that state-of-the-art emotional TTS doesn't necessarily need massive human-labeled datasets anymore, which is huge. But as we kept coming back to, the major challenge that remains is evaluation. Reliably, accurately measuring emotion in speech, especially the subtle stuff.
Right, where even the best LLMs today seem to fall short of human perception.
Exactly. It suggests that while AI is getting incredibly good at generating convincing emotional expression, truly understanding and evaluating that emotion, well, that's still a frontier.
Which leaves us with a thought for you, our technical listener. If even our most sophisticated AI models struggle to truly evaluate the nuances of human emotion in speech they generate, what does that tell us about the sheer complexity of human emotion itself? And maybe, how far are we really from AI that's genuinely empathetic or emotionally intelligent? Something to definitely chew on. That's all for this deep dive into EmoVoice on AI Paper Podcasts. Do check out the demo samples if you get a chance. The link should be available. Hearing it really brings it to life. We'll catch you on the next deep dive into cutting-edge AI research.